In the previous part of this lesson, we saw what refraction of light is. It's simply the bending of light when it travels from one medium to another. The question I left you with was, why does light change its direction after entering another medium at an angle? Let's discuss that in detail. The change in direction of light occurs because of the change in the speed of light in that medium. When light enters another medium, there is a change in its speed. The speed may either increase or decrease depending on the medium. Note that when we say that the speed will increase, it does not mean that the speed will be greater than this value, which is the speed of light in vacuum. When the light is entering into the glass at an angle, it travels at a lesser speed than in air, and when it goes from glass to air, its speed increases. So it's because of this change in speed that the direction of light changes. But what if the light is entering perpendicular to the surface of the glass? Will its speed change? Yes, its speed will change, however, it does not bend this time. Yes, the refracted ray propagates in the same direction as the incident ray. Talking about the case when light enters at an angle, there is one more observation that we can make. Observe this part of the refraction. Observe the incident and refracted rays. We notice that the refracted ray is more towards the normal than the incident ray. When the light rays enter the glass from air, it bends, and it bends towards the normal. And from this refraction, we can see that when the light ray again enters the air, it bends away from the normal. So we can say that when the light travels from an optically rarer medium to an optically denser medium, it bends towards the normal. And when the light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. What do we mean by optically rarer and denser mediums, by the way? An optical medium is a medium through which light can propagate. Since both air and glass are transparent, light can pass through them. So, both of them are optical mediums. What about rarer and denser? If the refractive medium is optically rarer compared to the incident medium, then the speed of light in it will be greater. And when the refractive medium is optically denser compared to the incident medium, the speed of light in it will be lesser. Note that in both cases, we are comparing the speed of light with the speed of light in the incident medium. So what do we understand by this? How can we summarize it? When light is traveling from an optically rarer medium to an optically denser medium, its speed will decrease and it will bend towards the normal. Whereas when the light is traveling from an optically denser medium to an optically rarer medium, its speed will increase and it will bend away from the normal. Now that this is clear, I want you to understand another concept. Now, instead of a glass slab, we have water, and also suppose that the ray of light is incident in the same direction. We can see that this angle is the same in both the cases. So will the refracted ray in this case travel in this direction only? In other words, will the angle of refraction be the same in both cases? No, the angle of refraction will be different in this case. In fact, the angle of refraction here is greater than the previous one. So what can we infer? We can say that the refraction of a light ray depends on the material medium on which light is incident. Yes, light rays will be refracted by different amounts in different materials. But wait, I have a couple of questions for you. Talking about the case when light enters at an angle, how does the change in speed result in the change in direction of light? And why does this perpendicular ray not change its direction after refraction? I know you must be curious to know the answers. However, we'll understand this in the next video. It's really interesting. Make sure you watch it.